shot this day. Now, the glass that we have here is a similar glass that's been used throughout history, called a soda lime glass. I apologize for the wind, but there's nothing that can be done about it. So I'm not going to complain too much. It's pretty nice and cool, so I'll take that over blistering hot. The glass during the Roman times was very, very common. It was the plastic of Rome, being used for disposable perfume bottles, being used for souvenir cups at gladiatorial events and chariot races, small junk jewelry, if you will. It was very, very common. But with the collapse of the Roman Empire, suddenly glass becomes very, very valuable, used by nobles and kings, queens, warriors of renown to show you can have excellent, fine things under rough conditions. So suddenly it goes from being worth less than bronze, being worth as much as silver, half the value of gold, not 1/10 like today. So it comes to this. Would be one of the apex drinking vessels of the Viking Age, called a claw beaker. Each one of these is hollow. And you would have this, if you had enough prestige and wealth to have a glass cup, you would have a cupbearer, someone to hold it for you. We know this, they speak of it in the Egil Saga, one of the Viking sagas. Talk to me more about that nerdiness later. I'll get with you on that. So, Viking sagas, all the good stuff. But we're going to make one, a drinking horn, also found at some of the burial sites. And we're going to make it as close as we can to the one that we have in our documentation, but because I can, it will glow in the dark. That's just neat. If they could have, they would have. The more blingy, the better. That is the Viking way. So, my glass is the same sort of glass, a soft glass, or soda lime glass. Literally made with soda ashes from burnt plants, lime from limestone or crushed up shells, and silica, sand or crushed quartz, smashed up in this furnace at 2,000 degrees all day, every day. Glass is often known today as a super-cooled liquid. The hotter the glass is, the more liquid-like it's going to be, where the wind takes that and cools it off very quickly. Where it glows bright orange, the glass is still hot, yes. You can grab it with tweezers, stretch it, reattach it, cut through it with shears. Many times in my life. Back and forth it goes. Easy peasy. Look how the glass is cooling down and becoming quite clear, yes? But we can do that. You can grab it with tweezers now, and if we grab it now, it just shatters. So, your first lesson in glass blowing, as I like to say, is hot glass, easy to work. Cold glass, not so much. Seems very simple, right? And it is. We're going to add the most important thing to it, and that is that glass is a very poor conductor of heat. That means heat and cold move through the glass very slowly. It's very, 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 very good, and very, 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 very bad. It is good. We can heat one small section, make it hot, easy to work, change its shape, cool it down, and keep that shape. Really, that's all glass blowing is. Heating it up or adding hot glass, change its shape, cool it down. My glass is clear, as I mentioned. That would have been a supremely high quality of glass during the medieval period. Most of the glass being produced is a light green in color. Anyone out there remember why? Anyone? Because iron is the most natural contaminant of sand. And we color our glass by using metals. There's vegetable dyes, shellfish ink that you would use for clothing. Won't work in the glass. It gets dissolved, burned away. So iron for green, brown, black. Cobalt for blue. Silver for yellow. Tin or lead for white. Manganese, purple. Dark manganese, black. Copper, the most important metal of all during the medieval period, the late medieval period in Europe. Why? It gives you aqua blue, shades of green, and the darkish, streaky ruby reds. Of course, they have these colors, but they're fairly restricted in materials and who buys them. Who buys most of the colored glass? Church and nobles. People who can afford stained glass windows. Two different skills: coloring the glass and making the cups. This is really before that time. Look at the 6th through 8th century. So we're going to set up our bench, get ready to go. That wind is killing me. It's very similar to someone playing with your stove while you're trying to cook. It's interesting and amusing at first, then kind of terrifying once it's time to serve something. So, into the furnace we go. I'm going to do, yep. Okay. Leslie, can you get that picture ready for me? I know that I may have an extra copy of that page somewhere in my box of things. Perfect. Into the mysterious glass I go that glows in the shade. And you might say, where do you get such an eerie powder? Well, I made alchemy equipment, and the alchemist gave me some of this powder, and he assures me no harm will come to me. Usually I follow that up with, he's on a little island about 10 miles west of me. And since I live in the middle of Pennsylvania, that's really pretty funny. Anyone get that? Yeah, a little glowing powder, never hurt anyone. Just take this, go on your merry way. In truth, it's not radioactive. You can put almost any of the chemicals or elements of the periodic table into a glass, and you will get a brand new kind of glass. Really quite interesting that way. If you use uranium oxide, as we did during, I guess, the 40s and 50s and 60s, you get that what's called a Vaseline glass. Anyone remember that? That ugly looking, like, kind of snotty colored glass that they used to make that glowed in the dark. That didn't actually glow in the dark. It was fluorescent. It would glow under black light. Whereas what I'm using is phosphorescent. It will actually absorb light and emit the photons, giving off light. Swirled it up on there pretty good. We're going to do this 2 times. Try to get as dense and glow-in-the-dark material as possible. Probably should have started off with just more glass, but here goes something. Let this cool down for a moment. It's going to start a very small bubble. Just a little bit. This was a terrible idea. Did I mention the part about practicing being useful? Because right about now I'm thinking that would have been even more useful. Just put a little bubble in there and put the bubble back out. Just put a little bit. That's going to make a big difference later on. That might be able to be twisted back up still without filling the bubble in. Maybe. We got to get a little bit cold. Why? Anytime we touch the glass with tools, it cools it down when we touched it. Anytime we go back in the furnace, that fresh heat will soak into our glass and make it really start moving around pretty quickly. I need a few seconds to make sure I get this thing good and cold so I can wind this new glass around our starter core. I'm realizing now that as a bigger gather from the very beginning would have been the wisest course of action. But hindsight, there you are. So what we're going to do on this drinking horn makes it a little bit different than the other designs of the Viking era. Some of the designs in the Viking era are very specific. Most of the vessels are drinking horns, drinking cones, what's called a bag beaker, rounded bottom vessels. Why is that? Well, they don't put them down the way we do. They drink out of them till they are done with the vessel, and then they put it down on the table. It's very specific about the etiquette. Often, it was very important for the lady of the house, whether it was a queen, or a princess, then their daughters, and then the servants. And the reason they did that was to show the highest level of hospitality that they could to their guests.